Alright, we're going to look at 9 through 11, which is concept 25. Here on number 9, researchers randomly selected 550 people between the ages of 40 to 70 for a study on the effects of caffeine. On the effects of exercise on the length of time people sleep at night. So that first sentence is important because it says that the researchers randomly selected the people. Now, the subjects were randomly divided into two groups. Half of the subjects were told to exercise for 30 minutes per day, and the other half was told to refrain from exercise. That's also an important sentence here. The subjects were randomly divided into two groups. The average amount of sleep for the group that exercised was 7.5 hours, but was only 6.2 hours for the group that refrained. What is the most appropriate conclusion? So the two things I highlighted here are the key things we're looking for. They randomly selected people for the experiment. What that means is that any conclusions from this study can be applied to the general population. The fact that they also randomly divided them into two groups means that whatever the conclusion was, so in this case the exercise people slept more, we can say that there's a cause and effect relationship. Or in other words, exercising caused people to sleep longer, or lack of exercise caused people to sleep less. So let's look at the multiple choice. Here we say we have no conclusion can be made since the ages were restricted. That's untrue. We can still make conclusions even though it's only for certain age groups. B, no conclusion can be made since the subjects were randomly divided. This is the opposite of what's true. Since the subjects were randomly divided, you can make a cause and effect conclusion. And exercising causes an increase in the average amount of sleep for all people. That is not true because this was only people between ages 40 through 70. And here exercising causes an increase in the average amount of sleep for people aged 40 to 70. That is true. It is true because there is a cause and effect relationship, and we can say all people from 40 to 70 because they randomly selected people from the population. Alright, number 10, a study of 50 random people found that approximately 66% of people eat fast food at least once a week. And this is a dot plot that shows 100 trials of the study. Draw two lines that represent an interval that captures the middle 95% of the simulated results. The middle 95% of the results is within 2 standard deviations of the mean. So here the mean is given 0.66, which is right here. And we want to capture 2 standard deviations from the mean. That'll give us the 95%. The standard deviation is 0.03. So 1 standard deviation would get me to 0.69, and 2 standard deviations would get me to 0.72, which is right here. So I'm going to capture all of that. That means these 3 dots right here will be not included. So we need to go also 2 standard deviations below the mean. So 0.66 minus 0.03 is 0.63, which is right here. And then 1 more standard deviation of 0.03 gets me to 0.6. So I'm going to put my left boundary right there. So these dots and these 3 dots are not included. So the interval that we've just created has a low of 0.6 and a high of 0.72. The margin of error is defined as the difference between the mean and either of the boundaries. So in this case, we can say 0.72 minus 0.66, which is 0.06. Or you could look at it as the distance from the mean to the left boundary, which is also 0.06. A follow-up survey found that 57% of people ate fast food at least once a week. Would this difference be considered statistically significant? Another way to think of this question is, would this difference be considered statistically surprising? So 57% is 0.57. 0.57 lies outside of our 95% interval. So we would say that yes, this is statistically surprising. 0.57 lies outside of the 95% interval. Okay, last one here. We have a medical student conducted a study to determine whether sleep or caffeine is more effective in enhancing people's memory. We have 24 people who participated. They were kept awake for 24 hours and then randomly assigned to 2 groups. The first group of students was given 150 milligrams of caffeine. The second group was allowed to sleep for 6 hours. So we have 2 different sets of data here. Following the treatment, the students were given a list of 100 words and asked to memorize as many as possible. We're going to look at a back-to-back dot plot here. For the caffeine group, we're going to do it for the sleep group. It's already done for you. So the sleep group is below the number line. The caffeine group will do above. So I'm just going to put a dot next to each data value. 6, 7, 10, 10, 12, 12, 13, 14, 14, 15, 16, and 18. Now we're looking at comparing the center and the spread of the distributions. Let's look at the center question first. By looking at our dot plots, we can see that the median or the center of the caffeine group has a lower value than the median of the sleep group. You know, the median here for the sleep group, if we just started counting, 1, 2, 3, 4, 5, 6, it's somewhere right here. But then for the caffeine group, if we start counting the median, 1, 2, 3, 4, 5, 6 is about right here. Okay, so for center, caffeine group has a lower median than the sleep group. Now spread refers to how far apart the data values are. The caffeine group here, we can see the range is 18 minus 6, which is 12, a range of 12, versus the sleep group here has a range of 21 minus 9, also 12. So the spread looks about the same, the range is the same. Okay, and then the last question, what can you infer from these results based on the setup of the experiment? So this is similar to what we did on number 9, looking at how they set up the experiment. Let's look for the keywords here. We have people, 24 people who volunteered. That means they were not randomly selected, but they were randomly assigned to 2 groups. So in this case, because they were randomly assigned to 2 groups, we can say the sleep group recalled more words. And we can more specifically say sleep caused the group to recall more words. So just changing the format of that sentence. So sleep caused the group to recall more words, but this can only be applied to the people in the study, not to the general population. So we'll say can only apply findings to people in the study, since they didn't randomly select them.